Alright, so today we're going to talk about single-phase compressors, how they're set up electrically, and the types of relays that you're going to come across to start them. Now this only applies to single-phase compressors. Single-phase compressors are the only compressors that will have a relay to start it. Three-phase compressors do not require a relay, which is one of the good things about three-phase, is that it requires less starting components to start the compressor. Basically just need a contactor, which is a giant switch, and they're very easy to reverse, unlike single-phase motors. So now if you pull off the back of a compressor terminal, you'll have three terminals. Looks like a triangle, just three different studs. So what those are connected to are two windings inside. So you have a common terminal, which is the junction of the start winding and the run winding. You'll have a start winding, which consists of a large or smaller wire, more tightly wrapped, higher resistance winding, and then a run winding, which is a lower resistance winding. Now, the start winding is too small to have to be engaged all the time. If power was on this start winding all the time, it would burn out, which is also one of the reasons why we have an overload in line with these, which I'll show you where that goes. The run winding is in the circuit all the time whenever the compressor is running. So basically this start winding is only in the circuit momentarily to get that compressor up and running, and this run winding runs that compressor all the time. The start winding is only for the starting load of the compressor. Once that compressor starts to get going, then we can run off the run winding only. That's why when you put your amp probe on the compressor and first start it out, you'll get a really high amperage rating, and then all of a sudden it'll drop. That first high amperage rating is what's called locked rotor. The compressor isn't running, it's drawing a ton of amperage. A relay triggers this start winding to turn on, that amperage drops, compressor starts up, and then that start winding drops out. So now, usually they're always, well, not always, but usually they're marked on a compressor, and you can easily tell them apart. Usually the back cover of the compressor says common CS&R on it, and that matches the terminals. There are some kind of funky, and they're always usually in this triangular configuration here. Sometimes the terminals are sideways, sometimes they're upside down, depending on the compressor make. I've seen some really funky ones out there. So if there are no indication of which terminal is common start and run, and you need to know, there's a very easy way to do it. So just for example, you take your ohm meter, you want resistance, and you want to read the resistance across any two terminals. So your start winding, say you get, let's say 10 ohms, and then here you get 5, and then here you get 15. So you can kind of see what's going on here. Your largest resistance reading, now they're never going to be this perfect, they'll be a little bit funky, and sometimes they may not, due to noise and other things, they may not equal exactly this, but your largest reading that you get, whatever terminal that you're not touching, when you get that reading, is your common terminal. Your start winding is going to be your next highest reading, and your run winding is going to be your lowest reading. And that's how you can tell common start and run terminals without knowing, without having them labeled or having a wired diagram. Now, the most common relay on anything that is under half horse. So if you have a compressor that is under half horsepower, 99.9% of the time, you're going to have what is called a current relay. This may or may not be junctioned with a start capacitor, and it will usually have some sort of thermal overload. The thermal overload will just be one of those little clicks-on discs. Unfortunately, I don't have one here to show you. But let me make another diagram, and I'll show you how this is actually hooked up to the compressor, and we'll take a look at these. Okay, so here's a basic diagram of what we got going on here. So 99% of the time these are going to be on 115 volt units, and that's what you're going to see, so that's why we're taking 115 volts. So We have a overload right here. We have our relay right here. We have a capacitor, which may or may not be there depending on the size of the compressor. We have our start winding and our run winding. Now when we wire these up, we want to make sure that we have our line voltage on the overload. We want to break power into the compressor, not the neutral out of the compressor if this ever triggers. So in its neutral state with no power to it, this relay is in the normally open position. So we're gonna say flip the switch to the compressor, usually through a thermostat or something like that. Power is gonna come in, go up, feed both my start and run winding. You can see my start winding is coming down here, but it can't go anywhere because this relay is open. My run winding is gonna get power. It's going to go through the coil of the relay and back to neutral. So now what's going to happen is this compressor isn't going to be able to start. And it's going to draw a lot of amperage because it's trying to start. What that does is creates a magnetic field in this coil here, which takes and closes these contacts. That will allow power to come through my start winding, through capacitor if present, and directly out to the neutral, basically putting my start winding into the circuit. Compressor is going to start to run now that the start winding is in place. Compressor is going to run, it's going to speed up, and the amperage is going to drop. When the amperage drops, it's going to demagnetize this coil, drop out this contact, and take my start winding out of the circuit, and my compressor will be able to run on the run winding only. And that's how they work. Now, failure mode on the relays themselves, barring an actual dead compressor that's either seized or electrically screwed up, failure mode on these little relays are kind of twofold. Sometimes the capacitors can go bad, which obviously a great indication of that is electrolytic fluid everywhere and the capacitor blew up. Or you can check with the meter and see if it's actually within the stated microfarad range or not. The other problem we have with these is this contacts are normally open, so they're open like this. Now when this starts, it's drawing a lot of amperage. As those contacts get closer and closer together, when they're really close together, they tend to arc. So all the time you have this open and closing, or closing and open, closing, open, closing, open, closing, open every time the compressor starts, and every time it closes you have an arc, and that arc is building up carbon deposits and pitting on the contacts. Eventually the contacts won't make contact anymore when they go to close, and the compressor won't be able to start, or they'll weld shut and keep the start winding in the circuit all the time. That's also bad because this can't take that power for very long. There's a reason why we have to take that out of the circuit, which is where our overload comes in. If this compressor overheats, this overload will break, shutting off the power to my compressor and hopefully not burning it. Now it all depends on how long it takes the customer to notice it, how long it takes them to call you, how long you take to get there. There's a lot of different factors in this to actually saving the compressor. When you go there, you put your hand on the compressor, you can like cook an egg off the thing, it's so hot. And also when it goes to start, you'll hear it hum and click. You'll hear click. It's not humming because it doesn't know the words, it's humming because it can't start. And that click is the overload relay, or the overload sensor here, opening. Now, these relays here, they're pretty cheap inside when we go and look at them. Also, there are very many relay and capacitor combinations for this, so you cannot humanly possibly stock all the combinations on your truck. But what you can do is use a 3-in-1. So basically in this, and we'll take a look at one of these, all three components, the capacitor, the relay, and the overload, are all in this one little package, and they're generic. You can see right here, this is half horse. This is rated for a half horse motor and up to 13.3 amps. This one, which I'll probably never use, which is the one we're going to look at, is 1/12 to 1/5 horsepower. And that is what? 4.05 amps. Alright, now there are drawbacks to using these, okay? Don't get me wrong. I love them personally. I use them all the time, and I leave them in units. Some people use these just to get the compressor started and go get the correct relay and then go back. You can do that, but the only problem is something killed this relay, and more than likely it did some damage to the compressor, and that new relay that you put in there won't last as long as the old relay you took out. Now these things can last a little bit longer, but they're generic, so they don't have, there are things that in here that might be a little bit different. This capacitor rating might be a little bit higher. The temperature rating of the overload in here might be a little bit higher. The overload isn't in direct contact with the compressor. It's in this. It's sensing the temperature of the relay itself. So it's not as good as one that's actually touching the compressor. But I'll be honest with you, I use these all the time, and I tell my customer, like, hey, look, I can get you this one. It might take me a little bit, or I can put this one in. The only problem with putting this one in is that, you know, it could last a day, it could last a week, it could last a month. You have no idea. You're not clairvoyant. You can't see into this compressor. Just tell your customer the truth and let them make the decision. But I use these things all the time, and I love them. Some people hate them. Some people say that they kill compressors. But I'll be honest with you, if this thing kills a compressor, that compressor was dead anyway. So, I mean, that's my opinion on these. So let's zoom in on the bench here. We'll take a look at both of these relays apart. Okay, so here is your relay. You can see the coil here, right? And then here is where it will plug into your compressor terminals. Now, a lot of times up top here, it'll be labeled as S and M for main winding and start winding, which you can also use as an indication to figure out which one to start and run. And like I said, a lot of times there'll be a capacitor across the top here, and then your power and everything will be hooked up to these terminals here. So let me pop this top off and we'll see what this is inside. Okay, so we have this sucker apart. So here's where the main winding plugs into, the run winding. You can see that's hooked in to the coil, and also this terminal, which would be a neutral. And here's where the start winding plugs into. Now this is a stationary terminal, and this is a stationary contact, and this is a stationary contact. So under here, and you can see that this is burnt when I take it off. See how black and pitted that is? There's one contact, and there's the other contact on the compressor. And this right here is the plunger contact that's going to spring up and bridge these two contacts to let the start winding get power. So inside here is a little plunger with a spring, and here is your second set of contacts. Now let me see how good I can zoom in on these, and you can see how burnt they are. Okay, you can see those are pretty ugly. Alright, so let's take a look at the 3-in-1. Okay, so here's how you'll get your 3-in-1. And as you can see, we have mine that goes to common, start, and run. And here's our power. Now these inside are completely different. So what we have at the bottom is just a standard capacitor. But inside this gets a little different and pretty cool. So inside here, if I can get it out, inside here we have our thermal overload, and it's just a bimetal strip. Okay, it's two pieces of dissimilar metals that are bent like a curve. When they heat up, one expands at a different rate than the other and basically snaps those contacts in the opposite position. That's how those work. This here is our relay, inside, and it's completely different than the other ones. There is no moving parts in this. This is a PTC relay, positive temperature coefficient. It's basically a giant ceramic resistor. When it's at room temperature, it allows electricity to pass freely through it, but as this heats up, the resistance goes up, which will eventually stop the flow of electricity through it. So when the compressor goes to start, electricity can pass freely through this, and that start winding is going to get power. Now the start winding is, the resistance value is high. It's going to start to heat this relay up, and this relay will eventually stop the flow of electricity into that start winding, effectively taking it out of the circuit. So let me see if I can get this open here. Okay, so here is what's inside there, and there is our PTC relay with two metal plates touching it, just like that. So this will allow electricity to flow freely through it. As it heats up, resistance goes up, eventually stops the flow of electricity through it, which stops the flow of electricity to our start winding. So that's how those work. Now, as I said, these are generic parts, so the rating of this overload may not exactly be what's on your compressor, and whereas the old one was in physical contact with your compressor, this one is in contact with this relay, and the heat from this relay is what will trigger this. Not as good of a situation as if this was right up against the compressor, but they do work. I do use them, and like I said, it's a very good option for a relay replacement. And you can look online everywhere and you find 20 different opinions on these, but my experience has been good with them, and I will continue to use them until I have a bad experience with them. So now let's go on to a little bit of a beefier relay configuration for larger compressors. Alright, your larger compressors are going to use this, which is called a potential relay. It's a little bit beefier. Usually anything over half horse is going to use these in connection with a start and a run capacitor. The overload relay will be built into the compressor or directly on top of the compressor, and we'll break the common wire to it. Let me make a quick diagram for this. I'll show you how this guy's wired into the circuit and how this one works. So a potential relay here is a completely different animal than our current relay. It has a start and a run capacitor, and our run capacitor is in our circuit all the time. This provides some running torque and evens out some voltage spikes and some other stuff, and then our start capacitor down here. Now the other major difference here is these contacts that control our start winding are normally closed, meaning with no power to our circuit, that contact that connects our start winding with our neutral line out is closed. So what happens here is basically the opposite of a current relay. Still, our power comes in, goes through our overload, and to common. From here, it feeds our start winding and our run winding, and then also branches off and feeds a coil that is built into the relay. These numbers here are the terminal numbers on the relay. So power is going to come in. It's going to go through our run winding here and directly out to neutral. It's also going to come in, go through our start winding. These contacts are closed through our start capacitor and out our neutral. So as soon as we apply power, this compressor starts running. There's no little bit of a delay for that coil to close and then open. Now our compressor starts to run. We have to take that start winding out of the circuit. Well, how does a potential relay do that? Well, it's actually kind of cool. Once this starts to get up to speed, all that spinning mass of metal, that rotor, that compressor, actually starts to create a back EMF pulse across this line, which then energizes this coil. This coil pulls up on a rod and boom, breaks those contacts, kicking our start winding out of our circuit. So once that compressor speeds up, that speeding up of the compressor actually energizes the coil, which kicks out our start winding. It's a very, very more robust system because you're not getting that arcing of close, open, close, open, close, open, close. All this is doing is opening a set of contacts, but it's opening that set of contacts once that compressor is pretty much up to speed, so there's not as much amperage and arcing on that contact. Not to say that they will never go bad, but they're much more robust than that current relay that's sitting there doing this all the time, which is why you see them on larger compressors. Now when we take it apart, you'll get to see everything inside there, so why don't we put you on the table and I'll show you what's going on. Now, just for replacement issues, we have the same issues on this as we have with the current relay, meaning that there are a ton of these relays for each different compressor. Reason being is because that coil in this has to be calibrated to the actual EMF, the back EMF that is produced by the compressor. So it needs to match. Now they do make generic ones of these that have an adjustable dial on the side that will allow you to change the pickup voltage and everything else. You can get those numbers. There's big compressor books that you can get that have all the actual information of the compressor. It will tell you what the pickup and drop out voltage of these relays are. What I usually do is I do carry one of the generic ones in the truck, and I just call the supply house, give them the model and serial number, and they're able to provide me with the pickup and drop out voltage so I can set the generic ones. Now, there are also tons of different run in stock capacitor combos with this, and the biggest thing with these is the capacitors going bad. But if you're changing the capacitors, do yourself a favor, change the relay. Change all the starting components at once. Don't just change one thing. You'll be sorry. So now I already have this apart. You can see here the terminals 1, 2, 5, and 6, and you can see that it's labeled. They're labeled right here. Here's the coil. Okay. So, and also just one other thing to point out. Right there it says top. There's a reason for that. Okay, just got stuck for a second. So there's our top when you pull it apart, and you can see that that will leave the contacts on the bottom side. So you want that so that there's no gravity acting on that. Okay, so now you can see these contacts are a little burnt, all right, but you can also see that they are closed, normally closed. All right, so you can see here that we have a spring pulling back on this rod, which is pushing up here through this. This is a little hinge, and allowing those contacts to close. It's in this position all the time. You can see I don't have power to it. Those contacts are closed. So now the compressor starts to turn. We create a magnetic field in this coil here, which pulls this rod towards it, and as it does, you can see that it pulls it out of the circuit, that it opens those contacts. So once that compressor is up and running sufficiently fast enough to energize this coil, that energizes and boom, kicks the start winding out. Then the compressor the power gets terminated to the compressor. Compressor slows down, magnetic field dies off of this, and then that spring returns those contacts to the closed position. So there is the only time that you're going to get any sort of chance to arc is going to be when this opens, but it's opening after the compressor's already running, so there's a lot less arcing going on there. Now this is probably burnt out because the compressor itself died, or one of the capacitors in there died. So if a capacitor dies and the compressor doesn't start, it's just like the regular the other compressor where you go there and it just sits there and hums and clicks. Now your best bet before you condemn the compressor is to change out the starting components. And like I said, don't change just the capacitors and leave the old relay in there, because you can see how burnt that is, and you're just asking for trouble. Replace everything. Even if you just check your capacitors and only one capacitor reads out of spec, do yourself a favor, go get the other capacitor and a new relay and replace everything in pairs. You'll be thanking yourself later. All right, and then obviously usually what we try to do is replace these parts, see if the compressor runs, and if the compressor doesn't run, then you have to replace it. But it doesn't really matter, because even if you replace the compressor, you have to replace the starting components. And on especially R22 systems now, they're getting into the habit where they change the compressors for refrigeration and air conditioning, reciprocating compressors, to be the same. The only difference would be that the refrigeration compressors will require a relay, a start, and a run. So make sure that when you replace the compressor, look in the box that you get and make sure that the relay, start, and run capacitor are in the box, and that you don't have to buy them separate. I've gotten burned on that a couple of times. But so that's the basic operation between this guy here, and as you can see, even the contacts themselves are way more robust than these little guys here. A comparison here. Here is a brand new one and what the contacts look like in that one. And again, compare that contact to that contact. Hope you guys enjoyed this video. I know I've been lacking on the AC vids and stuff like that. It's just been super busy at work. A lot of the stuff has been kind of, well, relatively routine, and anything that wasn't routine, of course, I didn't have the camera with me. But it takes a long time to actually do the job and film the job too. So hopefully soon I'll have some time where I can actually, where I'm not as overloaded, and I can actually just sit there and tape some of these jobs. But hopefully this video will tide you over until then. Planning on doing a little bit of a series of schematic wiring diagram kind of reading, kind of learn your way around the ladder schematic and pictorial diagrams and things like that. So those will be upcoming, plus the machine shop videos too. So see you guys on the next video, and thanks for watching. Click the like button, subscribe if you haven't, and we'll see you later.